Hi guys, I'm just going to quickly go through map exercises 1 to 5 so that we're all on the same page before you start the next set of exercises. This is especially for the external students who don't really have the opportunity to come to class and ask me questions about these map exercises, but you still have to complete the case study, so you still need to understand what exactly it is that we're doing with these map exercises. So the first one should have been very simple. It was simply two topographic profiles. The difference between these topographic profiles is the vertical exaggeration. So the first profile, there was no vertical exaggeration. We had VE equals 1. The other one was vertically exaggerated by 5 times. So we had VE equals 5. So from memory, the map scale was 1 centimeter equals 200 meters. So that's going to be your horizontal scale. 1 centimeter will be 200 meters. And because there's no vertical exaggeration, that will also be your vertical scale. So this will also be 1 centimeter equals 200 meters. The one down here, however, is vertically exaggerated. Remember, the horizontal scale along here is always going to be the same as the map scale. So this is still 1 centimeter equals 200 meters, just like the other one, but this scale was vertically exaggerated by 5 times. So we had VE equals 5, and so that means that 5 centimeters equals 200 meters on this particular scale. So that's really the only difference between these two. Otherwise, the topographic profiles should look fairly similar, it's just that this one has been stretched by 5 times in this direction. So I'm not going to spend too much time on that. The next cross section should look roughly like this. I've drawn these relatively quickly, so they're a bit messy. You guys should probably try and do a neater job of these. So we did a cross section from A to B on your map. And the first thing that you do when you do these geological cross sections, the first thing you need to do is draw your topographic profile. So I've drawn mine, it looks roughly like this. Some people were ruling these lines. I wouldn't rule the lines, I'd simply try and join them up as relatively smooth curves if you can. So don't just draw them like this. This isn't what hills look like. You don't often see topography looking like that, lots of straight lines. You see it being more of a curved sort of shape. So don't rule the lines, simply try and draw up the lines as smooth curves. Same goes when you're actually drawing a geology on. You don't need to use a ruler. Try and keep it relatively flat when we're dealing with this horizontal sort of rocks, or horizontal bedding like this, but you don't need to use a ruler. Just try and draw it across very carefully, draw nice straight lines across. So this is what the second exercise cross section should have looked like. Really the main trick with this one is firstly realizing that bedding is horizontal, and if you don't realize why it's horizontal, you need to go back to the lecture notes and look at the relationship between bedding and topographic contours. In this case they are parallel, and that means that you've got horizontal bedding. The other trick with this one is recognizing the hidden units, which were down here. So there was basalt and rhyolite on this cross section. Just because your cross section line didn't cross through either of those rock types doesn't mean that they're not still present at depth. If we go to the actual map itself, here's the map. Our cross section went across here like this. So we didn't actually cross the basalt and the rhyolite, which are down here, but we can tell how deep they are because the basalt, the contact between the basalt and I think this is a sandstone unit, we can see where that fits between those topographic contours. It's between the 150 and the 100 contour, roughly halfway. So I've said that this is around about 125 meters of height. This rhyolite is at around about 75 meters of height as well. So it's somewhere between the 100 and the 50 meter contour, which isn't actually on the map. So somewhere around about 75 meters of height, and that will do. So they should be present on your cross section because they're still present under the ground. Just because they're not present on the surface doesn't mean it's not important to include them on your cross section. Remember, your cross section is a predictive model. You're trying to say what's happening under the ground. Just because you haven't seen it on the surface doesn't mean it's not under the ground. So you do need to put these units onto your map. With these, all your cross sections always should still have a scale on them. They should have a key on them. I haven't actually drawn the key on this one because I've been lazy, but you get the idea. Yours should have a key. You should have labelled it A and B so we know where the two ends of the cross section are. You should have labelled height in meters above sea level. There should be no vertical exaggeration on this topographic profile either. And you should always have a title as well. So these are just things that you should be including on all of your cross sections. So just get into the habit now of making sure that all of these things are on your cross sections. I've seen in the past people including a north arrow, which doesn't really make sense on a cross section. There is no real north here. It's a slice through the earth, so you haven't got a north on here. The cross section actually went from west to east, so you can't see north on here. People sometimes put an arrow like that and say north. That's actually not north, that's up. We're looking at a different dimension here. So you got up and down rather than north and south on these topographic profiles and these geological cross sections. So hopefully exercise 1 and 2 were relatively simple. I'm going to stop the video here and then I'm going to start recording for exercise 3.